Welcome back everyone to final part 3 of the Capstone project solutions. And this is where we're really going to answer that question. Is Fandango artificially boosting the ratings because they also sell tickets? And if movies overall get higher ratings, they're more likely to sell more tickets. And we're going to answer this by comparing the distributions of displayed scores on Fandango with the distribution of review ratings across all sites. But there's a couple things we have to do first, such as normalize all the ratings to the same 0 to 5-star range. So let's head back to the Jupyter Notebook and finish off the project. Okay, so here we are at the notebook where we left off last time, and what we need to do is combine the Fandango table with the all sites table. Keep in mind that not every movie in the Fandango table is in the all sites table. If you check out the details on the GitHub that provided this data, the all sites table contains the movies that have at least 30 Fandango reviews. So that should be about 145 movies. What we're going to do is just do a simple inner join to merge these two together. So the way this works is I'm going to create a new data frame called df and say it's equal to pd merge. I'm going to merge Fandango on all sites on the film column. So keep in mind that the film column, you'd have to check beforehand to make sure that the titles are shown exactly the same way. In our case, this is already true. And then how is inner? Because I only want movies that are present both in all sites and Fandango. I don't want any null values here. Okay, and then if we check out the data frame, we now have 145 rows by 13 columns, so it looks like everything worked. Now we have the issue of these ratings not all being between 0 and 5. So that's the next issue and next task, is to normalize the columns to Fandango stars and ratings that are between 0 and 5. So Rotten Tomatoes, Metacritic, IMDb, they're not using the same 0 to 5 scores. So what we need to do is create normalized columns. Later on, we're actually going to explore scikit-learn and machine learning and the various ways we can standardize and normalize data. It's actually a really large part of machine learning. But for right now, we're going to go with this simpler way. I did give you a hint link that kind of shows the more complex ways. If you have questions on this, just go ahead and be patient because we cover a lot about normalization later on in the course, specifically in the machine learning section. For right now, we're going to do the simplistic way of this because I actually already know that if I have ratings that are 100 or 0 to 100 to normalize them to 0 to 5, I just need to divide by 20. Same for ratings that are between 0 and 10, just divide by 2, and they're all standardized or normalized to be between 0 and 5. So let's go ahead and do this on this data frame. I'm going to create a bunch of new columns called RT norm for this one, and it's going to be equal to, in fact, I'm just going to do the kind of standard way I'm going to do this. I'm going to say norm, so the normalized version, and then I'm going to round off the results of the column I'm interested in, divided by, let's say, 20, comma 1. So what's this doing right now? Well, I'm going to do this a bunch of times. So let me first copy and paste this and then explain what this placeholder code's actually doing. So what I need to do is for the various columns, I need to check what their range is, and then I need to divide by the appropriate number. So we're going to say df head here, or in fact, we can just say df describe actually, and then let me show that to you. And what I'm interested in is the max value. So what I'm also going to do is transpose this and then just select max. Okay, so you'll notice here that Rotten Tomatoes, that column is going from 0 to 100 because the max value is 100. So what I'm going to say is RT norm is equal to Rotten Tomatoes column. So we'll go ahead and paste that in and then divide that one by 20 because it's 100. And then what I'm doing with np.round, comma 1 is just rounding it off to the nearest decimal. So that way everything is something like 4.5 instead of 4.567 or something crazy. Same thing for the Rotten Tomato users. So if I look at Rotten Tomatoes users, that max value is 94, essentially implying that it goes from 0 to 100. So we'll go ahead and also divide that one by 20. So we'll go ahead and run that. And whoops, forgot to import NumPy. So let's import that as well. Import NumPy as np, run that. Okay, so the next ones we're going to do are Metacritic and Metacritic user. So Metacritic looks like it goes from 0 to 100. Metacritic user only goes from 0 to 10. So we have to keep that in mind. So we'll say meta norm is equal to Metacritic. That one goes from 0 to 100, so divided by 20. And then we'll say meta, say just U for user. That one goes from 0 to 10. So I'm only going to divide it by 2 to standardize it from 0 to 5. And again, this one's going to be the Metacritic user. So all we're doing here is we're dividing by the appropriate number to convert either the range of 0 to 100 to 0 to 5 or the range from 0 to 10 to 0 to 5. And I'm rounding it off by 1 just to get some nice numbers. Last one I'm going to do is the IMDb. So we'll say IMDb normalization. Looks like its max value is 8.6, so I'll assume that it goes from 0 to 10. In theory, it could have just gone from 0 to 8.6, but we kind of already know, and you can use our sensibilities to just say there was no perfect 10 movie on the IMDb score. So we're going to divide that one by 2, and this one's going to be IMDb. All right, so if I check out the head of my data frame, I should be able to see now, scrolling all the way to the right, all these normalized versions. So I have RT normalized, Rotten Tomatoes users normalized, Metacritic users, and IMDb all normalized from 0 to 5. So now I can directly compare them to stars and rating. So what we're going to do is create a norm scores data frame that only contains the normalized ratings. The reason for this is just because it's going to be a lot easier to just pass in this entire data frame into a distribution call. So lots of different ways we can do this. Probably the easiest way is to just call df columns and then just copy and paste this list of the normalized ones. So I'm going to copy and paste this and say, let's see, what did we call this? We wanted to call it norm scores. So norm scores is going to be the data frame. I'm going to pass in a list of those normalized scores. So I'm just grabbing all the normalized scores here. And then what I also want to do is grab the stars and rating columns. So we'll say also grab stars, rating, RT norm, RTU norm, meta norm, meta-U norm, and IMDb norm. So when you run this, and then check out the norm scores, at least the head of it, you should now see something that looks like this. So we have all the scores, they're all between 0 and 5. It's time for what I call the moment of truth. Is Fandango actually displaying abnormally high ratings? We already know for a fact that the stars being displayed on the website are higher than the true numeric rating. In theory, that can be forgiven just because of the displaying factors that are hard to associate with a filled up 5-star bar. We don't want to blame Fandango too much for showing 5 stars when the rating was something like 4.8. We did see there was a few cases that for whatever reason it showed up to 1 star higher for that weird Turbo movie, but that could be forgivable. However, what if all these other scores are much lower than stars and rating? That's where the moment of truth comes into play. So we already know it pushes ratings slightly higher than true stars, but are the ratings themselves higher than average across the entire industry? So what we're going to do is create a plot that compares this, and essentially what we want is this sort of distribution plot. Keep in mind, lots of different ways you can do this. Essentially, at the end of the day, what you want is something that clearly shows the truth. And you'll notice the truth happens to be that this curve for stars and the curve for rating peaks out at much higher and showing many more movies being rated between 4 and 5 than what is average across the industry. We can see IMDb seems to be kind of normalized around 3.5. It's probably what you would expect. And everyone else is kind of almost uniform compared to the stars and rating of Fandango, which is kind of crazy. That is essentially proof that the stars and ratings on Fandango are just way out of norm for some of these movies. So how can we do this? Probably the easiest way is to just say sns.kde plot or .this plot, whatever you want, and just say data norm scores. And pretty much if you do this, you get the plot. Now, everything else is just kind of organizing the plot. A couple things to note here is we're already going from x limits of -1 to 7, so we probably want to clip this off. Keep in mind, I can also do this as a this plot. So I could say this plot, run that, and I start to see the distribution. And you can clearly see here stars going much higher. So lots of different ways we could show this, but I prefer the KDE, looks a little nicer. And what we're going to do is start editing this so it's a little more readable. Technically, I can tell that stars and rating are a little higher, but the range is already kind of incorrect. I should clip this to 0 to 5 because I know those are the only possible scores. So we'll say clip this from 0 to 5, and I'll keep running this so we can see how it gets updated. So I'm clipping from 0 to 5. So far, that's good. I kind of like how it's shaded. I can see where they overlap. So let's go ahead and say shade is true. And now we're getting this nice shading I also like how this figure is larger. So what I could do is say plt figure and say fig size is equal to something. I think I chose 15 by 6 and then choose a higher DPI. So say 200. So here we can see the distributions themselves. I also chose a different palette. These colors, for my eyes, they looked a little too similar. So the palette I chose from Matplotlib is called Set1. Ran that, and technically, by this point, we're kind of done. We can see clearly that stars and rating are much higher on average than all the other movies. Okay, so clearly we have kind of distinct evidence that Fandango is rating movies a lot higher. Now, whether or not they're doing it on purpose, that's a little hard to explain with the data. We technically don't know. Maybe just people that are commenting on Fandango love movies and they think all movies are good, so that's why it's being rated. But we've already proven that the displayed rating on average is higher than the true rating, and now we've proven that just Fandango really loves movies compared to everything else. They're just rating movies way higher than most people are. Okay. So I also mentioned here that there's a quick note if you have issues moving the legend for Seaborn for the KDE plot. This is actually a bug that is not a Seaborn bug, technically speaking, but it's something that lies deeper within Matplotlib. So if you click on this GitHub link, basically for KDE plots, it's a little tricky to move this legend given what we already know about legends. If you say plt legend and try to set it at a different location, let's say 1.05 and 0.5, it'll kind of error out and say, hey, I can't handle this. And that's because we're passing in the entire data. We can't actually automatically label all that. So because there's not a clear way to reposition that, it's actually an open GitHub issue. Maybe by the time you're reviewing this, it's not an issue. You can just fast forward for the rest of this video. But what's nice about this is 𝑀ichael, who's actually the creator of Seaborn, a very cool guy, he gave us the function to fix this. So we can actually just copy this function. And then what we're going to do here is paste it into this cell, and then say kind of the rest of his fix, which is move legend ax upper left. We're going to copy paste it, move legend ax left upper left. And to fix this, what I need to do is actually set this up as subplots. So that's based off what is shown up here where we said fix ax plt subplots. So if you read that full open issue, hopefully it's not open by the time you're viewing this, but just wanted to kind of explain what was going on there. And let's put that in. So we run that, and now we're able to move the legend. That's kind of a hack around an issue with Matplotlib and GitHub. Full details are in this link. Okay, so clearly Fandango has an uneven distribution. They really like movies, and something I want to explore here further is the official critics from Rotten Tomatoes kind of uniformly rate movies. However, the stars displayed on the website are just crazy high compared to this. So let's go ahead and kind of really have this sink in. I'm going to grab this figure access code and make the same plot, but now let's just go ahead and grab those two columns. So instead of passing all the normalized scores, I'm going to say pass in RT norm and then pass in stars, which are the stars displayed. So you run that and you get out this plot, which really drives the point home. Official Rotten Tomato critics, more or less, they're scoring movies uniformly. They do tend to score more movies well, so there's more 3, 4, maybe 5-star movies. But Fandango, it's extremely unlikely to even score anything below a 3-star, which kind of implies there are no bad movies. So we can also optionally create a histogram comparing all these normalized scores. So what you could do if you want is just say something like SNS histplot, pass in the normalized scores, and then just make a bunch of bins. Kind of a different way of showing the same information. And whoops, SNS dot histplot. And we can kind of see this. Obviously, you can resize as necessary, but this shows you the same thing. You can see here huge spikes from stars versus everything else. Again, really implying that we have a lot more higher star ratings from Fandango. Because keep in mind, all these have the same number of movies. So theoretically speaking, they should all be showing kind of the same distribution if everyone was rating movies the same. And here is kind of an expanded resized version of that. So let's talk about the worst movies rated across all platforms. One really fun way to see this is with a cluster map. So what you can do is just create a cluster map of all the visualized movie scores. So to do this, it's actually really simple. We just say cluster map, say norm scores, and I like magma for this. So it's just a color mapping. And then I'm going to say column clustering is false. I only want to cluster based off the ratings themselves. I don't want to cluster based off the sites. So we'll say column clustering is false. And so what is this actually displaying to us? Well, what this is doing is it's clustering movies together based off their ratings across all sites. So that means that very likely if a movie is really bad, that more sites are going to rate it poorly. So those are then going to be clustered together. So essentially what we have here is the color bar where really bad movies that on average are getting bad ratings have a darker color, and really good movies have a very light color. So Seaborn is automatically clustering these based off their ID, and right now we can see that Rotten Tomato critics tend to be the harshest. So whichever column was darkest here, that's kind of your harshest critics. But you should notice that in general, you kind of see these patches of purple along these rows. And that makes sense because these are essentially bad movies that everyone's rating poorly. But what should really stand out to you is across this kind of bottom half, which is like the bottom half of the worst movies, the stars and rating for Fandango are still not even close to rating movies as poorly as things like Rotten Tomatoes and Metacritic. So here is yet another visual example of just how much Fandango is pushing up the ratings for these movies. So clearly Fandango is rating movies much higher than other sites. So what we're going to do is just grab the 10 worst movies and then discover what that distribution looks like. So what we can do here is let's go ahead and say normalized films is equal to DF. And if we take a look at norm scores, the columns we have here are stars rating. So we're going to grab all these, but also what I want is the film title. So grab all those and let's have another set of braces here. Essentially what I'm missing from norm scores is the film title itself. So we're going to grab all these from that original data frame we created. And then what I'm also going to do is grab the worst movies, and we're going to base this off the Rotten Tomatoes critic ratings. So we'll say norm films, n smallest, 10 for RT norm. So you run this, and this should be essentially the 10 worst movies in the dataset, according to the Rotten Tomatoes critics, which are kind of the harshest. We already know that. So what we're going to do is visualize this. I'm going to say that these are the worst films. And let's visualize the distribution of that. Many ways we can do this, but we can essentially just copy and paste what we did already. So we're going to scroll up here to this KDE. Let's go ahead and grab this one. Scroll down. Going to copy and paste it here, except now we're going to say data is the worst films. Run that, and you should see something that looks like this. So clearly what's happening here, we can see that Rotten Tomato critics that are normalized really kind of are harsh on these films. Not a single one of these films is really getting more than 1 star or maybe even 2 stars with Rotten Tomato critics. So if you're a really bad movie, the critics are going to get you here on Rotten Tomatoes. But what's kind of crazy is these are the 10 worst movies in the data set, and the distribution for Fandango scores is centered around 3.5 or 4 stars even. And these are the 10 worst movies. So Fandango, even for the worst movies, it's still showing them as kind of okay or average, which is kind of insane. So obviously, it all ends here. Taken 3, this is probably the worst offender out of these movies. And so if you actually explore this, basically, we already know that the n smallest, if we take a look at worst films again, we can see here that Taken has 4.5 stars. And again, this is displayed stars on Fandango. Its true rating on Fandango is 4.1. And this brings us back to the very start of everything we talked about. So you're back in 2015, you take a look at Taken 3, it says, hey, this is a 4.5 star movie, when basically everyone else is rating it very poorly. And we did a little bit of the math here for you, but you can see here for Taken 3, on average, it has a 1.86 normalized score across all the other sites. And if you were back in 2015, Fandango would have shown it as 4.5. Okay, so I hope you had a lot of fun with this project. You can check out the Wikipedia article as well as the 538 article on this for all the information around Fandango. A lot has changed in the past 5 years, so hopefully this won't be an issue in the future. Thanks, and I'll see you at the next section.